a whole bunch of people online for that. And we just wanted to follow up with some of the questions that were presented in that. We didn't get a chance to get to all of them. So I'm here with John Hyman from Appboy, and we're just going to start taking questions. We've got a bunch of questions already teed up in the sidebar, and we're just going to start knocking them off. If you have a question and you want to post it, go ahead and click on the Add Question button, and we'll get to them in order, and we'll just sort of chat back and forth about some of the things that have been coming up since the webinar last Wednesday, and we'll just kind of go from there. All right, so the first one is, what is the MongoDB advantage? Where would someone see that MongoDB would faster than relational DBs? So this is a good question, and I think this one requires a little bit of context. MongoDB isn't necessarily faster at everything. MongoDB is a tool in your toolbox, and it is something you can use to for specific workloads, and it may or may not be more performant in those use cases. So, you know, it's really up to the application designer to do the proper data modeling and to make sure that the fit for MongoDB is appropriate. So, when you're designing your applications, you know, think to yourself, hey, is a document model, or is the MongoDB document model really the right for my problem? And if it is, then great. Let's make the most of MongoDB, make the most of its capabilities. Things like secondary indexes, nested arrays, great use cases like it's very easy to index arrays of elements like tags. So there's a great set of very rich use cases that MongoDB is great for. And the real trick is to make sure that it's the right thing for your purpose. Once you do that, then you have a hope of actually making it faster than a relational DB because it's a great fit for your application. Good question. All right. Next one, how would you build the MongoDB cluster or similar to address the scenario where one server will go down? Will the application need to handle the server's availability, or will it be handled by a load balancer? So I think this is an ObjectRocket specific question, but I'll talk a little bit about MongoDB itself and its availability structures. So MongoDB has what's called a replica architecture. What that basically means is you have a primary database and as many slaves as appropriate for your use case. In the ObjectRocket scenario, we have a primary and 2 slaves. The slaves are replicating, or secondaries are replicating the data from the primary, and they are eventually consistent. So there are a few operations behind the primary at any one time. When there's a fault, let's say the primary's memory goes bad, or the processor fries, or the disk goes bad and the server goes down, then there'll be an election, what's called an election in MongoDB. The driver will be aware of that, so the driver that's interacting with this replica set will understand that an election is happening, and when there's a new primary, operations will continue. So there's a couple of caveats to this. One is, for read operations, the driver will retry, I think it's up to 3 times in fairly rapid succession to do that read, so it gives you some time to have this failover. Operations, you'll immediately get an exception, and so your application needs to handle that exception. So one way to handle it would be, hey, you immediately, you know, throw an exception to the calling process and say, hey, I can't do it right, or maybe you queue that right, or maybe you retry that right. So some application design is involved when, you know, dealing with failover from a MongoDB election. From another component, I guess, of ObjectRocket that's you know, part of that is the load balancing. So by default, ObjectRocket's sharded, and that means that the MongoS, or the data router, is part of the architecture. And ObjectRocket has a load balancer in front of those MongoS's, so you never really need to address n MongoS servers. You can address them as one logical host name or VIP and port. And that simply just allows customers to have a very easy access point. They don't need to worry about addressing servers or having complicated connect strings. And if one MongoS were to die, the load balancer automatically handles that. So that's another component to the availability architecture of ObjectRocket specifically. All right. Next question is, how many shards does ObjectRocket's biggest customer need and use? So this is sort of a loaded question, so suffice to say that we provide shards in the multi-hundred gigabyte range, it's not uncommon to see 250 gig shards or sometimes 500 gig shards, and customers can allocate those shards as needed as they grow. So folks, if they have, let's say, a terabyte workload and they need, say, 2 shards, each at 500 gigabytes, if they're going to grow another half terabyte over the coming, say, quarter, they might add another 500 gigabyte shard, or you know, more, twice as many 250. So that's just a strategy for growth. We have customers into the multi-terabyte range, and you know, you can build those multi-terabyte clusters and tens of terabyte clusters using the 250 to 500 gigabyte shards. There are practical limits on MongoDB for how many shards to add, and you know, typically we don't like to see 500 shards or 200 shards, but it's not uncommon to see 10 or 20 or things like this, so tens of shards easily. Good question. All right, so here's a good one. Can you talk about the performance gotchas around hotspots due to incorrect shard key, rebalancing of shards, etc.? This is a good question. So we talked a little bit about shard key design before, and shard key design is a key element of scaling MongoDB. You must be aware of your application, and you must know what keys make sense. So let me just give an example of, say, a Twitter clone. If you're going to build a Twitter type application, you may have a collection called tweets, say, and in the tweets collection you had a user ID. That was the user that owned that tweet. That user ID might be a good shard key. What that would mean is when you went to fetch all those tweets by that user, that was a local query that would all go against one shard. However, your feed that was, you know, spread across many users would not be. That would be a scatter gather. So those are the kind of things you need to think about when designing your application. What thing are you trying to tune for? In some of the talks I give, I talk about it's a compromise. If you read the docs from 10gen, you know, we should really help change those because they make it sound very black and white. You either chose a correct shard key or you didn't. Well, it's not that easy. Shard keys are generally a compromise of how many scatter gathers you're going to do, how many local queries you're going to do, and trying to just optimize around making as many local as possible. So don't feel bad if you've got 100 queries going against your cluster and 10 of them are scatter gathers and they're for the reporting team or something. That's not failing at designing shard keys. That's simply doing the best with what you have. So another technique is using hash-based shard keys. Now this is simply just taking a key, doing essentially an MD5 sum on that key, and storing that as the shard key. The effect this has is it's perfectly balanced from a data distribution standpoint. The caveat is it may not be perfectly balanced from a workload standpoint. So check out the docs and pick the right type of key for your workload. All right, and let's see. I think there's another part there. Like, what about rebalancing? So if you choose an improper shard key and now you have, say, shard 1 with 80% of the data, and shard 2 with the remaining 20% of the data, how do you rebalance that? So there's a couple things. One is you can always manually move chunks. You can divide up your data into smaller chunks and move those chunks from shard to shard. This is a manual activity, and it's really kind of a DBA activity, and I don't kind of recommend it. So the best thing to do is to really pick either a great shard key, so something that has good cardinality, something that is quite distinct. So zip code, say, would be a bad one, but maybe user ID key would be a good one. So things like this. And then if it does get out of balance, and you find that you made a mistake, or maybe your app evolves over time, you may need to rekey those collections. Techniques to do it at scale using replication, but in the simplest case, you'd have to export the data and re-import it with a new shard key. So that's the manual fix, if you will. All right. How does Appboy use MongoDB and ObjectRocket? So I guess I'll take the first part of this one, and then we can go let John talk real quick about that, about his use case as well. So we're very, very excited and very proud to have Appboy as one of our customers. Appboy started off with a small footprint, and it's grown over time as their product has become so successful. They are a standard plan like most folks, and they're sharded like most of our plans. And we've grown over time with John and John's application. We've been fortunate because John is a fantastic Mongo engineer and knows Mongo pretty well, and as you'll see, and is building his application around sharding. So I don't know, John, if you have some comments about that.
Yeah, sure. So I'll kind of talk about the beginnings of Appboy and when we started to use Mongo. So there's some advantages that Mongo has given us, and that have been really beneficial to us as we developed our application. So as Kenny mentioned, we started pretty small, and in the last year we've really seen a tremendous amount of growth. So with Mongo's flexible schemas, we really had the ability to be very agile with our development. So we could change schemas on the fly, add things, remove things. We didn't have to do a lot of cumbersome database migrations. So Mongo really gave us the flexibility to be very agile. But then once our application became more mature, we started understanding what our schema was, how we're going to use Mongo, and then things kind of solidified there. And to that extent, we get the benefits of flexible schemas around like analytics and things like I explained in the webinar. But basically, we use MongoDB for all of our, what I just say, like user data or really application data. We use a lot of different databases. We have like Amazon Redshift. We're almost done building out our Hadoop cluster. We use Redis. We use MongoDB. And really what we want to do is we want to store like application level things in Mongo. So things like physical devices like iOS devices, Android devices, what apps are on the Appboy platform. We kind of store that data in Mongo just like you do in a relational database. And for most part, we're not taking advantage of the flexible schema. Like, for example, apps all have like a name and an image and a description. They belong to a company. So it's kind of relational in that sense, but it can get more flexible when you go and talk about like what a user looks like. And if you recall from the webinar, I talked about like users can have custom attributes. It's like our customers can log any kind of arbitrary data they want to user. So that's where we get the power out of Mongo. And so as Kenny's mentioned, that we've grown a lot, and infrastructurally the way that we use Mongo is we have a few different shards set up, and we're actually starting now to cluster out certain collections. So one thing that's cool about Mongo is you can scale the entire cluster horizontally. So you can start with one database and then go to 2 and then 3 and 4 that are horizontal, and they have all your collections on them. So say you have 100 collections. But what you can start to do is then you can break off other collections and then shard those. So if you have like a really large collection, like hundreds of gigabytes, you could just move that single collection to 5 machines. Then the rest of your collections could be on another 5 machines. So you'd have 10 total, but the distribution will be split. And that gives you some different advantages depending on your read and write pattern. So that's kind of what we're doing infrastructurally. And Kenny and the ObjectRocket team have been really helpful in terms of recommending infrastructural changes, scheduling maintenance with us, working through everything with us, both from a response time perspective and also from a knowledge perspective and helpfulness.
Great, John. Thanks. Yeah, so I can add to that a little bit too. So, one of the things that we typically recommend. We do a lot of sharding here, and I do a lot of talking about sharding. And sharding can be a hot topic because it's more complicated than just using standard Mongo. And one of the things that's come up in the past, and I think John was alluding to this, is that how do you really plan about scaling your application, or how do you really tackle that when you're starting from zero and maybe you don't know? So a couple things here. One of those things is to think about splitting your application logically before you try and scale it horizontally. So what I mean by that is I was talking earlier about this tweets example. Let's say you had a collection that was your actual tweets, and let's say you had a collection that was your actual user login and their phone or whatever other personal information you need. So those two collections, you may want to logically divide them into separate instances or even separate databases. And the goal of this is that each workload can then be presented individually, and every attribute of that instance can be dedicated to that purpose. So let me give you an example. For instance, the cache on that particular instance, the MongoDB cache, is only dedicated on one side to tweets, and the other instance it's only dedicated to users. The benefit here is that when you have a high tweet workload, it doesn't push users out of cache and maybe cause login slowness, and vice versa. When there's a high, say, login load or new users are coming on, that doesn't affect your ability to cache tweets. And so by splitting up your workload in these logical buckets, it can help you think about how to scale applications out. And so then you play these tweets and add shards to that particular instance, and users and add shards to that particular instance. So it's a really nice way to logically break up your application and grow it and scale it. Now, the caveat is your application has to understand that there's two different connect strings. There's essentially two different logical databases to use for those things. So you must join them in the app. Now, in a relational database, you might not have done that traditionally, right? You might have joined tweets and users and returned one big payload. But in Mongo, really, since you're not joining, it's already naturally built to kind of do this. So it really, really aids in scaling. You can say, well, I can't join, or I wasn't planning on joining users and tweets together anyway, because you can't really do that. So in your application, you would have had to think of this anyway. So it makes it really natural, frankly, a natural cut line for how to scale. And so I think that's, that's one of the things John was talking about there. All right. So let's go on one here. If you choose a region in ObjectRocket, can you still have replica sets spread across separate data centers? The answer is no, not today. So when you provision an instance on ObjectRocket, we take great care of creating a very high available or a highly available replica set with 3 members. Those 3 members are in the same data center, and they are spread on different racks, different power supplies, fully redundant. Frankly, they're completely separate. And the point of that is just to provide the most availability per data center as possible. We do, on occasion, replicate data from those across the country to other clusters for various purposes. But when you provision a default instance, that's not the default configuration. And there's a reason why. So the reason why is replica sets need to have fast access to the primary. Basically the way it works is a secondary will read the log, which is a journal of all the changes on the primary, and that needs to be applied very quickly to the slave. If not, those slaves will start to lag, and the eventual consistency will start to become more and more eventual. And if you're reading from those slaves, then your data become farther and farther apart and less consistent. So we try and have a predictable product and a predictable outcome for customers, and by staying in the data center, that makes that happen. Typically, availability within a data center is not a problem. Typically, the faults you see are, disk goes bad or a CPU or whatever, and the default construct of a MongoDB replica set works great for that. So that covers availability very well in those cases. All right, let's see. Next question is, curious to know why only Mongo is selected, not other NoSQL databases, i.e. RIAC. So two things I think to answer this question. So ObjectRocket today is a Mongo service. It's a Mongo-only service. That is just where we started. The demand and I think needs in the marketplace for something on Mongo was great, and that's why we built ObjectRocket. And frankly, MongoDB was one of the first databases to really take advantage of our platform, and I'll talk about our platform a little bit in a second. The other point is that, all these tools are important tools. So it's, as ObjectRocket, we're not saying that Mongo is the right tool for every job, and we know this. Rackspace has a variety of product offerings from MySQL and Hadoop and other various offerings, and those need to be selected, based on the task at hand. So the application designer needs to figure out, frankly, that solutions, which of those data stores is going to be the right data store for their particular problem. If you've got a big data solution and you need to mine billions of records and come up with a summated, grouped report, MongoDB may not be the answer, and maybe Hadoop is the answer. If that report needs to come out once a week and not instantly, then there's probably not a caching component, and maybe Hadoop's the right thing there. However, if you're doing something that is a document-based and naturally a document-based architecture or something that requires a flexible schema, then MongoDB is a great choice. So, you just need to compare and contrast those various solutions and pick the right one for you. And if the right one's MongoDB, then we think there's no better place to run it than ObjectRocket. So let me talk a little bit about the underlying platform, just for context there. ObjectRocket is a database as a service. When you fire on ObjectRocket, we automatically create an instance for you in Mongo. Like I said, it's a 3-member replica set and a single shard. And that really allows you to just get started. You can import your data and start building your application or start scaling your application. The underlying platform, we've tried to ensure that all the technical bits have been solved. So we use, we're based on Linux. I'll just kind of go through the technologies we use. We use X4 file system. We're all Fusion IO SSD, so it's PCIe flash storage underneath. So even at the smallest 1 gigabyte footprint, we still put you on Fusion IO PCIe flash storage. It's super fast. And I'll talk a little bit in a second about IO performance and why that matters for Mongo. Beyond that, each instance is completely containered from other neighbors, if you will. Noisy neighbor problem or typical noisy neighbor problems is not a problem on our platform. We use the OpenVZ container technology, Linux containers, to do that. Just like some of the other solutions, like the Rackspace DBAS MySQL solution does that as well. That solution is fantastic because it gives near bare metal speed while allowing us to container off I/O, memory, CPU, just to that particular instance that a customer may be using. An interesting side note there is, if you'll notice in the Mongo settings, NUMA or non-uniform memory addressing is something that is a little bit tricky in Mongo. Mongo takes advantage of a single core for the most part, but can address all the memory on a system. And so that can be contentious at times if left unchecked. So on our system, OpenVZ actually provides a nice container around that. We can actually restrict the CPU groups crosstalk such that we get a very, very high performance system. So there's some interesting tidbits there. So regarding Mongo and flash storage or SSD storage, the way Mongo works is Mongo uses memory map files, and those memory map files are pulled into memory and essentially used as cache. So it's not like other databases where they have their own shared memory segments or anything like that. It's simply it's Linux's memory mapping capability that allows the files to be cached in memory. So that's fine. That's all good and fine. However, MongoDB is also very, very locky. What I mean by that is it uses a locking mechanism that's based on yielding, not based on something like row-level locking or some other locking scheme that other databases have. So just take Oracle, for example. Oracle has row-level locking. If someone's updating a particular row until that row is either committed or rolled back, that row is mine, and I'm the only one with it. It's different on Mongo. Mongo actually yields. So if I'm operating on a particular document, MongoDB may actually yield to a reading process. That reading process can go read that image, return it to the calling process, and continue on. So those are called locks, and there's a way to measure that in MongoDB called lock percent, and you can see that in server status output. You can see that in MongoStat. And one of the big factors around lock percent, and it used to be really a big issue in 1.8 and 2.0 Mongo. It's less so now with the later 2.4 and upcoming 2.6 versions of Mongo, is that when you miss or you do a fault, you miss your memory and you go to disk, that lock percent can climb. So if you have an application that's doing, let's say you have an application that's 2 terabyte. Let's say you're just running on your laptop, just for sake of argument, and you have whatever many gigs on your laptop, just for sake of argument, say 20 gigs, and your database is, say, 100 gigs, you're not going to be able to fit that whole database in memory. You're going to be doing I/O. So the same thing holds true for MongoDB, and if you're going to that disk and your fault, you're paging out, you're actually having disk faults to go get those blocks to return those documents, then you need a fast disk subsystem, because while you do that, the lock percent may climb. So every time you do an I/O, making that I/O as fast as possible is very, very advantageous for MongoDB, and that's why SSD works so great, or PCIe Flash works so great. It really makes a lot of the problems around locking and performance in Mongo just go away. So we built our platform from day one using those technologies and knowing that to ensure that the response times were fast and the platform was fast. So just a kind of a primer there. All right, I think that is the end of the questions I've got so far. If folks are tuning in, if you go ahead and hit the Ask Question or Add Question button, and just go ahead and type in your text, and we'll get to it. So, John, I thought maybe you could just talk for a few seconds about your application design around MongoDB, and maybe just a couple quick thoughts around considerations when designing for Mongo.
Sure. So there are a few things in general, like I guess kind of principles that you want to look at. One, the approach that we took, being part of an analytics service, is that we didn't want to use Mongo for everything. So this is kind of what Kenny was saying, is that you need to use the right tool for the right job. So like as I mentioned in the webinar, Appboy receives billions of data points each month from our customers. And we thought about logging those data points to Mongo. And I'm talking about like a data point would be like an event happened at this time from this user on this app. It's very simple structure. But the amount of volume that we get is just simply too high, in that we thought Mongo wasn't optimal for it. So like one thing that Mongo does, it memory maps all of your files. So that means that at any time Mongo is going to write something, it's going to actually put that in memory. And when it needs to update something, it's going to pull it disk, put it in memory, and then write it back out. So what happens is and Kenny kind of alluded to this, you get memory pressures from other reads. It also can block other writes. And so we thought like, would we want to even go at that data? You look at that data and kind of query over that data in Mongo. We thought, no, it's not really the right tool. For those kind of data sets and those sizes, we wanted to use something like Hadoop or a data warehouse. So first thing is just kind of figure out what you think makes sense. So for us, a lot of those decisions were around user properties and a lot of and prior data analytics. And the benefits from that, kind of as I mentioned, is that we get to be very flexible. Our customers can log us custom attributes. And then with prior data analytics, we can log various different dimensions all very easily and cheaply in Mongo. So those are kind of the considerations that we use. With any schema design, I'd highly recommend you to look at Tengen's documentation on schema design. There's a lot of tips that they tell you to do in terms of like tokenizing short field names, overriding the primary key, and then there's some other like tricks that you can do in there that you can kind of read over those things. So just make sure you have a good grasp of that before you get started. One thing is like don't treat it always like a relational database. Mongo has a great power to embed documents. So whereas in relational databases you'd be more prone to have foreign keys set up, you can start thinking about in Mongo whether or not you just want to put those all in the same document, which is very beneficial because if you want to pull a document with associated properties, you just do one thing like that. So as an example is, let's say you have like an action, and then it has like a bunch of settings, or maybe you have like a user of your app and he has like sign-in preferences, like for his email preferences. In a typical relational database, you might want to put those preferences in like a user preferences table, and then you have foreign keys between like which user has which preference, and you kind of do a join there. But in Mongo, you can actually create like an embedded user preferences document, put it in the user document, and then anytime you pull in the user, you have his preferences right there. You never need to do any kind of join or secondary query. So starting to think around embedding is a good paradigm and mindset for you to get into like when you get into MongoDB. So I think those are kind of like the high-level things around there.
Yeah, that's a good one. And I'll throw one out there too, right? So we talked a little bit about where like maybe Hadoop workloads can dovetail with MongoDB and how that looks. There's another couple of sort of paradigms. One is around faceted search. So just to kind of throw this out there. So if you're running, say, a clothing or retail operation, and it's very alluring to want to use MongoDB because all your product catalog is going to be very, very different, one item to the next, right? So you may have shirts, and those shirts have attributes that pants don't, and that skirts don't, and shoes don't. And the power of MongoDB is this schema can be flexible for each one of those things. And like John said, you can embed documents for various sub-attributes. So whatever toe style of a shoe, or I'm not a shoe expert, but or whatever pants, is it cargo shorts, and if it is, what kind of pockets does it have, or whatever. You can drill down on those various attributes. And so MongoDB seems to be a very, very good fit for that. However, there's a couple caveats. One of them is when you're trying to search based on those attributes. So this is just sort of, this isn't just Mongo. This is sort of this more database theory in general. So let's query by, again, like that example, cargo shorts by like zippered pockets. Okay, that's fine. You're going to want to put an index on that attribute. But what if now I want to search on shoes that have a 3-inch heel? Well, okay, I'll have an index on that one, and on and on and on. So you can't really realistically index every one of those attributes. So how do you do it? So there's a couple of techniques. One is you can use a completely different data store, like a column store, which doesn't necessarily need indexes, except now you lose that rich, flexible schema. Or you can still use Mongo for that catalog, for those items. So maybe you have a collection, called items, and it's got a type, shoe, pants, whatever, shorts, whatever. And then you use something like Lucene or Solar for the search. And basically what you do is and there's products out there called like River that take that oplog data from Mongo I was talking about earlier, they index it in the search engine, and allow you to actually build an application so people can search on, I need a 3-inch heel that's tan to match my outfit tonight, or I need cargo shorts that have a 4-inch zipper pocket to hold my wallet or whatever, and they can actually search on those attributes. And the returning component that comes out of the search engine is actually the primary key of that item, or a set of primary keys for those items from MongoDB. And so that's a very rich use case in which MongoDB can be paired up with other solutions to really have like a net fantastic application. All right, so in this kind of tees into this next question we have, which is, in your experience and opinion, how often are people not using just one, but many NoSQL technologies, i.e. Redis in front of Mongo? Do you have a favorite combo for a project you've worked with? So I'll start this, and it'd be cool to hear from John too, because I know he's using some of these things. From our standpoint, what we see the most with our customers is all our customers using MongoDB, but beyond that, Redis is a very, very, very popular companion. So a lot of people who are using Mongo are using Redis. Redis is a fantastic successor, say, to Memcache. And as Mongo, maybe people view it as a successor to MySQL. So folks are experimenting and using those technologies together often, and we see that quite a bit. We also see that people are using analytics components, whether it be as a service analytics or their own analytics. Sometimes it's even just in a relational database. So folks will pull data out, put it into MySQL or Postgres, and do their analytics in that component. And there's also then Hadoop. People are, if there's a very large workload and they need to pull that data out and do some processing on it, they will pull out in Hadoop, do some processing, and then perhaps put a payload back into Mongo. So you can imagine where, like, I need to distill down 1 billion documents, up with a summarized document that says, hey, most of the people in the U.S. are doing, whatever this kind of activity during this Super Bowl campaign or whatever. Hadoop is a great tool for that, to basically run MapReduce across a large number of data elements, return that payload, put that payload back in Mongo, and now your calling application has fast access to it. So that's a common use case as well. I don't know, John, do you want to talk about how you're using other technologies with Mongo?
Yeah, so as I mentioned, we have Mongo, Redis, Data Warehouse, and now we're almost done with our Hadoop cluster. So one of the things in there, someone said of like, do we have a favorite technology? I really like Redis. I read about Redis probably about 3 years ago. The author of Redis, Antirez, wrote a blog post that made Hacker News. It was called like How to Take Advantage of Redis Just by Adding It to Your Stack. And in there, I think he gave like 5 or 10 examples of cool things Redis could do. And I remember reading it and thinking that was just a really cool piece of technology. And I kind of started learning more about it, and I thought that there were more and more things that we could do with its concepts, like sets, sorted sets, things like that. Like we use sets pretty extensively. So it's like an example of what we do is as customers log like event data to us, we store the like actual event names, the distinct names in a Redis set, so that way we can show them on the dashboard. So like if we have a customer that has like a video sharing app, maybe they have like a custom event called like watched video or shared video or emailed friend, invited friend. They have all those different events, and on our dashboard we want to let them look at different graphs of those different events. Well, we don't want to do like the equivalent of like a select distinct name from events. It's just simply too slow. Instead, we just have a set in Redis, and we can get that cardinality in O of one time from Redis, and so it's very, very fast for you to like do things like that. So I kind of encourage like playing with different pieces of technology where you think you can get like performance gains. I looked at other NoSQL solutions when we were building this. When we started building Appboy, of course, we wanted to build for scale, thinking that we'd have a lot of users. One thing that is different about our service, or might be different from our service than yours, is that many others, is that we scale as like we acquire more customers, we get their users. So, for example, one of our clients is Text Plus. It's a very popular messaging app in the App Store. They have like over 50 million downloads. So as soon as they go live in the App Store, we basically bump up with all of those users. And as we acquire new users, we get their user base. And so we definitely wanted to build some scale from the beginning. I looked at other things. There were some great promising technologies. I did like a workshop on React. We looked at Cassandra, Couchbase, those things. But Mongo is just so easy to get up and get started that we kind of just chose that. And then have tried to add small, easy-to-manage things like Redis. Like I'd really recommend looking at Redis. It's probably the easiest thing to ever administer, like any tool to administer I've like ever seen. You get it up and running in like 15 minutes yourself, and I don't think you can probably say that for many other database technologies. So that's kind of how we went with it.
Yeah, that's good input. I guess I have one more while you were talking. It made me think about it. So some of our customers have a use case where they pull in sensor data, say from solar arrays or their power generation equipment, and put that into Mongo. And so another kind of, not necessarily NoSQL technology, but another technology that typically is paired with Mongo in that regard is queuing. So something like RabbitMQ or other queuing technologies. And the way that works, and the reason that's such a nice fit for MongoDB is two things, I guess. Their workload is to basically jam a ton of data into Mongo. That data requires a flexible schema, so Mongo works from that standpoint. But they don't necessarily have to receive that data. It's not a synchronous operation to what they're doing. They're just trying to put that data in, and typically it's a lot of data, so it's very concurrent. So a limitation of MongoDB as you scale can be that you're trying to do too many concurrent operations of the same type. So I talked about that locking component earlier. Imagine if you're trying to do, 10,000 concurrent inserts of a megabyte payload. MongoDB is going to be busy doing that. So one cool sort of pairing with other technologies is in a queuing system. What you can do is you can take that information and distill it down into like a single writer process or a few writer processes. So let's say I have 10,000 sensors out there across the world, and I'm going to make an API call, and I want to store that in Mongo. I don't necessarily need to make the API call directly to Mongo and wait for Mongo to write it. What I can do is I can make that API call to a queuing system. That queuing system can stash it and store it, and then it can have a different level of concurrency to the database. Call it 4 or 10 or 20, but not 10,000. And what that does is it yields much better performance overall. So sometimes serializing is actually faster than a high level of concurrency when locking is involved. So by doing that, you get an asynchronous write to the database. You get to control the concurrency to the database, and so it's very easy to scale those components. It's very easy to sort of administer those components, and you can point that queue to whatever database. Say maybe you have a different collection per month or whatever. It's an easy sort of control point to switch it to various different collections whenever needed or whatever to maintenance. So that's another very popular use case that people are using it for. All right, so I think through all the questions here. If anybody's still hanging on and with more questions, don't be shy. Shoot them up there to the right hand pane and just click on them now. Otherwise, I think we're starting to wrap up here.
Thanks. Actually, I'll kind of hop in and just say a final thing on that queuing. One thing that MongoDB lacks is transactions. So it's hard, basically impossible in MongoDB alone to like add, update, and remove multiple objects, especially across different collections all at the same time. So one thing is you can look to like other solutions to kind of bridge that gap. And either, like for example, like Redis has transactions, and so we use lots of Redis transactions in our app. But you can also then bring in like this global distributed locking to kind of enforce those kind of transactions, which also we do as well using again Redis. So there's like with the queuing thing, there's like things that you might want to look at depending on the database technology and figure out like what makes the most sense for how you need to put data in, and then what happens when you dequeue data and how like atomic that needs to actually be.
Yeah, great point. All right, so hey John, thanks a lot for joining. I appreciate it. It's good input, and thanks everybody for watching. We really appreciate it. You know how to get a hold of us. My name is Kenny Gorman again. Kenny.Gorman@Rackspace.com or @KennyGorman on Twitter. If you have any follow-on questions or anything else, I'd love to chat about this stuff. And if there's stuff for John, I can take them and grab John's answers or whatever and get back to you. So appreciate everybody joining today. It was great, and hope to talk to you soon. Thanks.